Hello, my name is Gracie Han. I'm here to present this project 3 along with Don Padma-Peruma. So we are asked to use the name database to perform the classifier of gender, male and female. We were told to split the data into 3 subsets: training set, development test set, and the test set. And then we were asked to come up with a few models and compare themselves. So in summary, we have chosen 3 models based on previous students' jobs, and so we chose 3 of them, and we perform analysis using Bayesian model as also the classification tree model, and we compare the performance on the development test set and the trainings and the test set. So first, load the library and the database. As we can see that there are 7,000 something names split into 70% female and then 20% male. And then the first letter graphed, as we can see that it's a very overwhelmingly C, L, M, T as in the female, and then in the male, S and W as a first letter. And then we shuffle the letter, shuffle the database, and then take a look at the duplicated names. So there are some duplicate names, and after removing the duplicates, there are 7,214 unique names. So this is the data set that we're going to work on. So first, we split into 3 sets: training, development test, and test data. Before we do any analysis, we have this function that in the future that's called performance metrics that will compare male and female subset. This will be for the future usage. So we come up with 3 features. So the first feature we chose as first letter, last letter, suffix, prefix, counting of the letters in the vowels, and then we chose A, E, I, O, U as our vowels and leave out the Y as option, and also taking into consideration if this has a vowel or not. So this so here is the first name that by this feature. So we split the data into 3 sets based on this feature: 500 for the test, 500 for the development test, and then 1,000 for the training. So on this first feature, we first apply naive Bayes model, and so using the accuracy method that is built in with the naive Bayesian model, the accuracy is around 0.84, 80%. And then here are the 5 most important features. And so we have this check error function developed. As we can see that out of these names, there are 82 errors, meaning that the guess was the opposite of female versus male. And here are the names, for example, Cherish, Corliss. These names, they guessed wrong. So there are 72 of them. And then the accuracy for the development set using this feature is 0.83 and 0.81, which is similar to before. And then here are the performance matrix that we used before to look at the difference between male and female, subset. As we can see that the recall error for male is 80, and then for female is 85, and for the training set, and then similarly for the development set. So there's not much difference with feature number 1. Also, on feature number 1, we applied the decision tree classifier, and then we can see that the accuracy is around 80 for test and development test sets. So here, the decision tree and for this first feature, the decision tree and naive Bayesian model perform similarly. The second feature we chose last letter, so it's a very simple feature compared to the first feature, which was taking into consideration of 7 of the characters. The reason we chose this is that other students have performed similar analysis and feel that the last letter really makes a difference, so we want to see. And then even that this is a very simple feature, meaning only take into consideration of 1 letter only, and the accuracy by naive Bayesian model is not that bad. It's 60.646 and 0.668 for the development set and then test set. And here are the most looking at the male and the female separately, and we can see that surprisingly female recall error is huge at 0.96, while male recall error is very small. So the last letter overwhelmingly will help develop in identify male name, and it's not that helpful in identifying female names. So this is a very important and pronounced feature. Here are the most important features. As we can see that W has a 5.7 chance of predicting as a male than a female, meaning W as the last letter, and so is Q and K. While Z, there's not much difference. There's only 1.7 times difference of predicting a male versus a female. And we apply the decision tree classifier and then end up with 0.66 accuracy, which is not bad considering that we only take into consideration of 1 letter only. And so we apply the third feature, which is last 2 letters, to see if adding 1 more letter, if it improves. And so here is the functions, and then the accuracy is 0.82 and 0.80 for the development set and test set, which is similar to before, not much difference. And then the female recall error stays at 0.9, so it does not improve, which is a very big recall error. It does not improve. Adding 1 letter does not improve, meaning last 2 letter and last 1 letter makes no difference. However, the recall error for male jumped from 0.1 to 0.67, meaning that adding 1 more letter actually hurts, meaning that the last 2 letters is not as good as last letter only for male. So this is a very interesting finding that one letter, which is the last letter, performs better than last two letters, at least for men. So there's another feature that we tried, which is a combo of letter vowels. First letter, first two letter, first three letter, last one, last three, last two, last three, and last vowel. So we use this feature to perform the vectorizing, which is listed below. So here is the example of Mary and Joe. After vectorizing, this is how they look. Then we extract the feature for the entire data set. The X contains the feature and Y contains the target. And then we shuffle the database and split into three sets like before, but using this vectorize only. And then we use the train the vectorizing to know the possible features and values. And so here are the type of transformation, and we print out the transformation and then the type of transformation and then the vector names for using example of Mary and Joe. So we apply the classification tree, decision tree classifier on this vectorized model, and you can see that the accuracy is 0.85 and 0.84, which is very good. And then finally, we have performed the cross-validation on the training, development test, and test score. So looks like that the cross-validation is around 80%, so it's satisfying. So this concludes this project. Thank you very much.